This naturalrefrigerants.com article is being read by an automated voice. Part 2. Zudek's Ammonia Chillers. Give data centers another option for moving to natural refrigerants, by Michael Hines. Published March 18, 2026. This is an excerpt from an article featured in Atmosphere's Clean Cooling for Data Centers 2025 report, which can be downloaded here. Atmosphere is the publisher of naturalrefrigerants.com. Zudek built its first ammonia chiller for a data center in 2013 in South Africa. Since then, it has provided chillers for 4 more data centers, 2 of which were in Germany. One with a cooling capacity of 700 kilowatts, 199 tons of refrigeration, and another with a cooling capacity of 6 megawatts, 1,706 tons of refrigeration. The company is currently working on a new data center project, but did not share specifics. Ammonia is not widely used in data center cooling, and Zudek acknowledges that there is still caution in the market. The company's chillers are designed with a low refrigerant charge and incorporate advanced safety systems. There is no problem using ammonia in an outdoor unit because the ammonia is lighter than air, and in case of a leakage, a sensor inside the unit raises the speed of the fans to launch the air as high as possible, said Fabrizio Amati, Sales and Marketing Director at Zudek. For chillers installed inside a building, every installation has a system that extracts the air, which can be run through an optional scrubber, to release the air to the atmosphere with just a few parts per million of ammonia. One of the aspects driving Zudek's push in the data center sector is the increasing regulatory pressure in Europe regarding PFAS, per- and polyfluoroalkyl substances. Many synthetic refrigerants, including some HFOs, are PFAS and could be banned in the European Union under the Universal PFAS Restriction Proposal currently being reviewed by the European Chemicals Agency. Amati emphasized that this could significantly impact the long-term viability of such refrigerants, while ammonia, being a natural refrigerant, remains a future-proof solution. Case study. In 2024, Zudek delivered an aromatic ammonia chiller with 790 kilowatts, 224 tons of refrigeration, of cooling capacity to a data center located in the German state of Baden-Württemberg that serves a company in the financial sector. The aromatic chiller replaced an existing chiller of the same size using R407C. In selecting its new chiller, the data center operator prioritized a system that would reduce its environmental impact, be energy efficient, and guarantee maximum reliability, according to Amati. The aromatic air-cooled chiller is designed to cool water to 11 degrees Celsius or 14 degrees Celsius, 52 degrees Fahrenheit or 57 degrees Fahrenheit, and is connected to a dry cooler with an integrated plate and shell heat exchanger for free cooling. Partial free cooling can be provided from an ambient temperature of 10 degrees Celsius, 50 degrees Fahrenheit, and full free cooling is available at 6 degrees Celsius, 49 degrees Fahrenheit. By contrast, the replaced R407C chiller could only offer free cooling from an ambient temperature of -4 degrees Celsius and 25 degrees Fahrenheit. Zudek's ammonia chiller can provide an annual average of 2,131 hours of free cooling compared to just 195 hours for the R407C chiller. Normally, chillers with synthetic refrigerants have an additional coil on the chiller itself, said Amati. We don't do that because it increases the energy consumption of the fans. The piping for an ammonia chiller is also different, so we need to use an external and more efficient dry cooler. Amati added that this setup enables Zudek to keep the glycol in the external circuit and only circulate water inside the data center, reducing the energy needed for the pumps, as they have a less viscous fluid to move. This focus on energy efficiency and free cooling, along with the general efficiency of ammonia, led to the aromatic chiller being 43% more energy efficient than the R407C chiller it replaced. This translates to annual savings of €185,752, $195,128.